Welcome to another great video. So now in this one we are doing a problem from the Eastern Cape. It was November 2023, and then this one was question 4, still on Newton's second law, right? Yes. So in this particular problem, if you check, we are given a diagram with 8 kilogram block and the 4 kilogram block, and these are connected via a string, right? So now we then have a constant force of 55 newtons being applied on the 8 kilogram block, or to the 8 kilogram block, so causing it to accelerate. So when this 55 newton force is being applied, the blocks both accelerate to the right. Okay, so we have that piece of information now, and then it continues. The kinetic frictional force between the 4 kilogram block and the inclined plane is 4 newtons. So we know that for this guy we have a kinetic frictional force of 4 newtons. And then while the kinetic frictional force between the 8 kilogram block and the horizontal plane is 8 newtons. So this guy is 8 newtons. Right, so what I usually prefer to do is, now before you start answering any questions, you just annotate these and you take out your free body diagrams. Right, so let's just annotate. So by annotate, I mean you take out all the forces that you've been given in this particular problem. So let's use a different color. Let's start with the 8 kilogram block. We know that the normal force is always just perpendicular to the surface, so it will go straight up like that in this case, right? Some people write it as Fn, still the same thing, and then it will have a weight going down like this, right? And then you have this force 55 being applied. I won't draw. Okay, you can draw it, but there's no need because it's already there, right? 55. Then you have a tension due to the rope, and then you have your frictional force as well, which is opposing the motion of this block. So the motion is going that way, and the frictional force is going to be that way. Okay, we can draw it. Let me draw it here at the bottom. That's my FK. Right, so we're done with the first block. It's everything, or every force that we need. Now we go to the second block, 4 kg block. I start with my normal force. It's always perpendicular to the surface. So the surface now is at an incline like this. So how do I make sure it's perpendicular? I draw a line perpendicular to that, right? So it will be going like this. That's my normal force. And then you have the tension going up there. And then you have your mass. Mass is always going, weight. Weight is always going straight down. That's my weight. Okay, so now since this weight is at an angle relative to our x-axis, our new x-axis, because remember we usually shift it for inclined surfaces, and then it becomes like this. Our x and y axis become like this. There's a reason we do that. It's just for convenience, right? You don't have to know how to or why we do that for now, but we always do it like that. And then it means this will have an angle of 30 degrees here between the y and between our new y-axis and the weight itself, right? We always put it there. That's 30 degrees, right? So it's one of those cases where you don't necessarily need to know how to shift the axis, but you need to know how to annotate once it's shifted. You won't be examined on how to shift it. All right, so now we have these two situations or scenarios, and then from here you can then draw your free body diagrams. So you can just divide it like this. This is obviously on your rough worksheets. You don't divide on your exam sheets. It's not allowed. If you divide, they might not mark your work. So you are just putting yourself at a disadvantage, and you don't need that. All right, so we divided it. There's the free body diagram for the 8 kilogram block, and then there's the free body diagram for the 4 kilogram block. FBD is just me saying free body diagram. I'm dreading writing the whole word. It won't even fit there for now. Right, so you'll have the tension, you will have the normal force, which is perpendicular to the tension. You will have, oh, we forgot something here. How can we forget? Our friction, which is opposite the direction of this block, the direction of motion of this block. That's F. Okay. So then you can have your FK there. And then now you have your weight going downwards, straight down. Then tension. Right, so now you have all these forces that were mentioned in the statement or in the problem statement. So let's go for the 8 kilogram block now. For the 8 kilogram block, remember we said we have normal force going up there, and then we'll have our weights. So this is normal force, then this is our weight. Then we have the applied force, which is 55 newtons going that way. I'll just label it as 55 newtons. This is our applied force. Then there are two forces opposing the applied force. First, we have tension. Let me do it like this. You have tension force, and then you have the friction. Right, so these are our free body diagrams. So once you sort this out, you know that whatever question comes, you can now solve for it, right? Because you've annotated everything. You are fine now. Okay, so let's start answering. Now 4.1. So this means now you understand the overall problem, what's happening, what are the forces involved, and so on and so forth. Okay, so we are asked to state the Newton's second law of motion in words. Remember what I always say, you just have to go to your list of definitions before any test or exam, 2 days or 2 to 3 days before, even 1 day if you can, and then you memorize all of them. The ones that you still haven't memorized, because some of them you will memorize during the course of the year or that term, right? But some of them you would have to remind yourself. So that's how you do it, so that you can back all these free marks, because this is a free 2 marks for just stating in words. Remember, the reason they always specify that it should be in words, because it can also be stated in an equation form, which is F net is equals to MA. So they always say in words, because they know we are lazy as learners. We might just write it like this, which would be very nice because our life would be convenient, right? But nonetheless, here they want it in words. So remember, it basically says if a net force is applied to an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force itself, but inversely proportional to the mass of the object. Okay, so that's all the Newton's second law of motion says. You just need to make sure it's in your head and you know it off by heart, okay, for situations like this. So yes, when a net force is applied to an object of mass m, the object then accelerates in the direction of this net force with an acceleration that is directly proportional to the net force but inversely proportional to the mass of the object. Also stated, F net is equals to ma. So that's what you need to do. Now let's go to 4.2. 4.2, we are asked to draw a free body diagram of all the forces acting on the 4 kilogram block. Okay, so we've already prepared a free body diagram. So let's just call this our 4.2, this whole thing. This will be our 4 point. But we don't want all these free body diagrams. We mainly want this one. So let me take it as is. They said the 4 kilogram block. So don't draw both free body diagrams because it's unnecessary. Why would you waste your time when the question clearly wants one? But when you're still interpreting the question, you can draw all of them, okay? I'm not saying don't draw all of them at all. I'm saying while you're still interpreting the question, draw all of them. But once the question tells you what it wants, then you can draw the one that's wanted by that question. So this is 4.2. So we are set, we are fine. See, we were way ahead of the question before we even started. So now we're asked to calculate the tension in the string connecting the two blocks. So for questions like this, whether it's tension, acceleration, and then when you see that you have two blocks that are being connected by an inextensible string, just know that whenever they start asking you for the tension or the acceleration, chances are you'll have to use both of these free body diagrams. So in this case, we have two. We have the one for the 4 kilogram block, and then you have the one for the 8 kilogram block. By using both, I mean that you must take F net is equals to MA, considering the free body diagram of the 4 kilogram block, and then whatever you find there, you then continue to the 8 kilogram block and take F net is equals to MA. Right, because usually what happens is you can't solve for these kinds of problems using only one free body diagram. Usually you need both of them. All right, so also the 6 marks there is telling you that this is probably going to be a calculation that is a bit longer. Right, so now let's start with the free body diagram for the 4 kilogram block. Okay, so we already have these. I won't redraw or resketch them. So I'll just say 4.3. Then I say 4 for the 4 kilogram block. So for the sake of your understanding, let me put it here so that we see everything we're doing for the 4 kilogram block. If you remember, we said there was an angle here. This weight is at an angle, right? And this angle is 30 degrees. I think that's what the question said. Yes, 30 degrees. So now what we then do is, since we want the tension, we will take the sum of the forces along that axis where the tension is located, right? We won't care about the vertical axis where the normal force is located because tension is not in that axis, okay? So let's consider all forces along the x-axis for now. So let me resolve our weight because it has two components due to it being at an angle. Remember, once a vector is at an angle, it is a 2D vector at that point, and it must therefore be resolved. So it will have a y component. So if you check, it'll have, that's our y component, and then it will also have an x component, which will be going that side. Okay, I made it too long. It's fine, I'll just extend it this side. I made the y too long. But yeah, then what happens is now you'll have your weight. We call it weight parallel. Some people call it weight x, which is weight, the component of the weight in the x direction, or the x component of the weight, and then the y component of the weight, which is usually what we call weight perpendicular. So it's parallel to the x-axis, but and then the other one is perpendicular to the x-axis. So, because remember, this is our x-axis. Our axis becomes like this now. You have this one being your x-axis, and you have that one being your y-axis. So in essence, we just tilted them for convenience. Right, so, but you don't need to know all of that. All you need to know is how to resolve this once it's at a slanted slope. Right, or once it's at an incline, sorry. So now, we want everything along the axis where tension is found, which is the x-axis. So we'll say net force is equals to MA, right? And then let's choose a direction. I choose the direction of the tension as my positive. The direction of where the object is actually going. The system is going to the right, so I'll just choose right as positive, okay? So which means anything opposite to that direction, I will regard as negative. That means my Fk is negative, and the parallel component of the weight will also be negative. Okay, so we have that. Now let's start summing. We'll have T plus, we said this guy will be negative, plus our weight parallel will also be negative, and all of this is equal to MA. A is positive because we took the direction of travel or the direction of motion of this system as a positive direction. So our A is also positive. We don't need to change it. Okay. And then now we have that. So now we can substitute and say T minus, we were told the kinetic friction of the 4 kilogram block, I think it's 4 newtons or something. Yes, 4 newtons. Minus 4 minus mg. So if you check here, our weight parallel will be W, or weight, sine 30, because it's opposite to the angle 30 degrees. So we'll use sine to find it. While the other one, the perpendicular one, will be, because it's adjacent to the angle, it will be weight cos 30 degrees. And remember, this is the same as just saying mg cos 30 degrees. Why? Because weight is equal to mg. So we just substituted weight with mg, okay? And then, same thing applies to the top guy. You'll have mg sine 30 degrees. Yes. So now, come back here. You substitute now. What's mg sine? We said mg sine 30 for weight parallel. So therefore, we will have 4. That's m. G is 9.8 sine. Okay, my S looks weird. Sine 30. Now it's better. Degrees, okay? And then our mass is 4 again times A. So we don't know what A is. We're not told. Right. So now we come here. So at this point, you see that you have 2 unknowns. So it means one must be the subject of the formula. So this question is specifically asking us to find the tension. So we have to make A subject because we're not looking for A, we're looking for the tension. That's how we usually do it. So whatever answer you get here, you'll then make A subject. So you'll have, let's see, minus 4 sine 30. So here what will happen is you'll get T minus 23.6, this is what I get, is equals to 4a. Then you can just divide by 4 both sides so that you make a subject. Therefore your a is t minus 23.6, all of that divided by 4. Okay, then we will call this our equation 1. In this case, it's the first equation that we get, so let's call it equation 1. Right, now let's move on to the 8 kilogram block, because this was the 4 kilogram block. This looks weird. Much better. Let's move it to the 8 kilogram block. So for the 8 kilogram block, we again have our free body diagram. Right, so now what we can do here as well is we take sum of forces, F net, right, so we take this direction as positive because that's where the block is going, or the system of blocks, that's where they are going. So right now we take right as positive. Okay, that means anything opposite this direction is regarded as negative. So let's substitute. We'll have our 55, right, plus our tension will be negative in this case, plus also our friction will be negative, is equals to ma. Right, substitute further, we get that 55 minus t minus, we were told that the kinetic friction here is 8 newtons, is equals to, my mass is 8 times 8. Okay, so 55 minus 8, you get 47. Okay, so this is 47 minus t is equals to 8a. Divide both sides by 8. Divide by 8. Divide by 8, making a the subject. Remember why we make a the subject? Because we're not looking for it. We're looking for t. So the one that you're not looking for must be the subject of the formula. This is our equation 2. So from here, we can now equate equation 1 and equation 2. Because A is the same in both block 1 and block 2, or in both the 4 kilogram block and the 8 kilogram block. Even if we're solving mathematically, we notice that A is the same between these two equations. So therefore, we can equate them. So we'll have T minus 23.6, all this over 4, right, is equals to 47 minus t over 8. So going forward from here, it's all just mathematics. Okay, it's all just mathematics. So what you can do is, I usually pick the side that's easier to manipulate. So for here, I'll just multiply by 8 over 1 so that I get rid of that 8. Okay, so let's do this. Let me just change the color so you see. This is 8 over 1. But what you do on that side, you must also do on this side. Right, so this gets rid of that 8. Now, for here, it gets rid of that 4, but it leaves a 2 here. That means you are left with 2t minus 23.6 is equals to 47 minus t. So now they are all over 1. There's no fraction now. We're just dealing with equations that we're used to. So from here, you can multiply out here. For instance, you'll have 2t minus 23.6 is equals to 47 minus t. So now we're trying to get t to be on one side. You can either say add 2t on both sides of the equation, or you can either add t on both sides of the equation. So by adding 2t, I mean subtracting it actually, not adding it, because you have to remove it on one side and make sure it's on the other side. So I'll choose to add t on both sides instead. Let me say plus t. Remember this mathematical rule, guys. It's just maths. So you must fix your maths if you don't get why we're adding t on both sides. It's just to make sure it's on one side. So if I add plus t here, it'll get rid of this t, right? And then I add here, because what I do on the right, I have to do on the left. So now, what you end up having is 3t minus, I'm taking it step by step in case there's someone who needs to see all of this, but I could have skipped from this part to just the answer. So, right, you have that. And then now, you can transpose this guy and solve for t if final. So you can transpose this here. All the stuff you would do in maths actually when solving for equations, especially simultaneous equations. And then what will happen is, that means, let me skip steps now. Okay, it's fine, let's not skip. 3t will be 47 plus 23.6, right? Because when you transpose, this guy changes the sign, becomes positive. If it was positive, it was going to become negative. All right, so that's what happens. Now from here, I can simply divide by 3 both sides. Then my t is equals to I get 23.53 newtons. Remember, without the units, your answer is incomplete. So this is how you tackle this problem, okay? So basically, that's what happens for this thing. There's a second method that you could have used. Is the one I've been showing you on the other videos as well, where you take the system as a whole. But in that case, you would find A and then use one free body diagram to find your tension. All right, so for now, let's use this method though. If you want the other method, you can watch the other videos. And then 4.4. 4.4 says the angle of inclination is decreased to 10 degrees. How will the change affect the coefficient of kinetic friction? Okay, we have that. So right, they increase the angle of inclination to, they decrease it to 10 degrees. Right. Now, how will this change affect the coefficient of kinetic friction? It's very simple. The coefficient of kinetic friction will not be affected by us decreasing a angle, right? It will remain the same. The reason for this is because it's a property of a surface. So it comes with the surface. It depends where that object is sliding, right? So if I take my hand, for instance, and I rub it against my desk, the coefficient of kinetic friction there will not be the same as if I take my hand maybe and let's say I rub it against a wall, a concrete wall. It won't be the same. Same thing if I take, I don't know, a book and rub it against a tire or rubber and so on. The coefficient of kinetic friction there will not be the same. It's a property of the material itself. It's not necessarily affected by us changing the angles in the system, like changing the angle of application of the force and so on. So that's very crucial. Right, so it will remain the same. What question is that? 4.4. We say it remains the same. remains the same. Why? Because it is a property of the material or the type of surface. Oh yeah. So we say coefficient of kinetic friction is only dependent on, so I want to say on the type of surface. So nothing else. Yeah, I think this is the shortest way of putting it. Right, that's your 2 marks right there. 2 marks for correct choice of the 3 choices you were given. Remains the same, increase, decrease. And then another mark for your reasoning. Okay, so this is, ladies and gentlemen, how you would tackle a problem like this one. And then, yes. So, great video. I'll catch you on the next one.